Hi, welcome everyone. Imagine there is an AI agent which can automate the whole process of exploratory data analysis, EDA. So, given a dataset link and metadata, the description about the data, if it can understand the data elements and generate a set of hypotheses or questions about the data, and then again it goes on to answer those questions by selecting appropriate statistical test or statistical plots, and then also making sense of those results, and then summarizes all those results into an EDA report. How to create such an AI agent? So in this video, we will dive deeper into creating such an AI agent using a framework called CrewAI. So CrewAI is one of the most widely used agent framework, and we'll first look at the agent that I have created, which takes an input of the dataset link and metadata and look at what report it generates, and then we'll dive deeper into creating such a tool, how to actually implement that AI agent using CrewAI framework. So here is the tool which takes input number of questions to ask to generate the metadata file which contains the description about the dataset and the dataset link, and of course I have also given an image path to store those generated plots from the analysis. Now let's look at what actually it contains in the metadata file. So this is the description about the data in the metadata file. A simple description about the data, some context about the data set, and the column names and the descriptions, simple descriptions. So this data set contains some samples about persons who are suffering or not suffering from CSD, coronary heart disease, and some health parameters like blood pressure, tobacco consumption, LDL, family history of heart disease, obesity, alcohol consumption, age, and simple description about those data elements. This is the only input given to the CrewAI framework. And now let's look at what report it has generated. So this is the report generated by the AI agent in a markdown format, which contains the dataset description. This is of course taken from the metadata file itself, and then these are the questions it has automatically generated from the data set, generated the code, run the code, analyze the results, and also summarized it. So let's look at the questions. How does the distribution of SBP differ between individuals with and without CSD? And what does this suggest about the relationship between blood pressure and the heart disease? You can see it has generated the code, and this is the code output. It actually has done a t-test on the blood pressure, and basically says that the t statistics, the p value is approximately very small. This indicates a difference in SBP between these two groups who are suffering CSD and not suffering from CSD statistically significant. This suggests the higher systolic blood pressure is associated with an increased risk of CSD in this population. This is the conclusion from the analysis. And it also has generated a plot showing the distribution of SBP between these two groups, CSD and no CSD. That's very nice. Now let's look at the second question it asks. Is there a significant correlation between tobacco consumption and LDL, and how these variables impact the risk of CSD? Again, if you see, it has done two things. It has actually done a Pearson correlation between these two variables, which is tobacco consumption and LDL, and it also has run a logistic regression model to find out the impact of these variables on CST automatically. The correlation between tobacco and LDL is this, the p-value of this. So statistically significant, but very weak correlation. But it has run a logistic regression model with CSD as an outcome variable and tobacco and LDL as independent variables, and you can see the p-value of that. And it also has concluded that the logistic regression results suggest both tobacco consumption and LDL are significant predictors of CST in this data set. And it also created a plot show the correlation between tobacco and LDL. You can see how beautiful report it is generated for 2 questions, because I asked to generate only 2 questions, but you can ask as many questions as you want. Of course, that's going to take time to run this agent if you ask more questions, and also going to cost money because it's going to interact with an LLM. In this case, it's an OpenAI. So now let's get into the implementation of this particular AI agent. Let's look at the implementation of this AI agent using CrewAI framework. I have created a CrewAI project. This template can be created using command in the CrewAI. The CrewAI create Crew new project name. It automatically creates the template to get you started very soon. So let me go to the structure of the project. Under config, it actually creates the crew, which contains the agents. So the agents are an autonomous unit programmed to perform tasks and make decisions and communicate with the other agents. So agents are typically, you can think like the role that we provide when we provide a prompt to the LLM, and the actual instructions, what the task is, they are actually given as a task itself. So the crew contains agents and tasks, and the tasks are assigned to the agents. So the agent is typically capable of doing one or multiple tasks. So tasks are very specific, what has to be accomplished, and agents are more like the roles that we assign. So in this case, I have created 2 different crew. One is called Quest and one is called EDA. So the Quest is the one that actually generates the question provided a data set and its description. So if you see, there's an agent called business consultant, and the goal is to generate insightful business questions. So an experienced business consultant is skilled at asking great questions based on the data and the metadata. So it's like a role in the prompt itself. And what task it is assigned, that's little more descriptive here. So below, that's a generate question task that's assigned to the business consultant. So below is a description of a data set containing context and the description of the data elements. So based on your understanding of the metadata, generate questions. How many? That's actually passed is a variable, which would give deeper insights. Questions should be about specific variables and based on the univariate and bivariate analysis. Should involve just one variable or 2 variables, limited to that for the time being. The insights should be based on some of the basic statistical analysis, like histogram, correlation analysis, a given set of things that actually to generate questions here, which of course can be changed. And this is actually metadata which can be passed later, that has been parameterized. And what is expected output? A list of questions as specified by schema. So schema is actually defined by Pydantic class, which of course I will show you later how it is passed. Now that's a quest, and then EDA, the agent is called a data scientist, and generate code to answer the question, execute the code, interpret and summarize the results, and proficient in EDA, statistics and machine learning. And the task is much more descriptive, much more detailed. So you are tasked with generating Python code, execute and summarize. You are given the following information: data set description, again provide the data set description here, and the question. So these are questions which would come from the quest agent, and that would be given to the EDA agent. And here the steps to follow. So for example, the code should use specific libraries. It should load the data, and can assume the data is clean for the timing. Use statistical tests and plots to answer the questions. Focus only on the question in hand and use variables that's necessary for the analysis. And also given instruction to store the plots generated in a specific location so that it can be included in the final summary document, and ensure the code is clear, efficient and well commented. Then of course the generated code satisfy the following conditions, right? So data set loaded from the specific location, code only use relevant variables, right? And the expected output finally. So generate the code, execute the code, collect all the output from the code execution, interpret and summarize the results for statistical tests and plots in the output. Now the expected output should be in a markdown format that's as given. It should contain the following sections: question, code, code output and analysis, the final summary of the results. So this is the complete detailed task that's defined here. So we have two crew, one crew which generates the question and the other one which will answer the question. And the EDA is designed to answer one question at a time. So based on how many questions we have generated, that many instances of EDA crew will be created and they will answer the questions one by one. And once this is defined, we can define the actual crew in the CrewAI file, and here is the Pydantic class per question, which is nothing but a list of questions which would be written by the quest agent. And there's also Python REPL tool is used because the code generator has to be executed. So it's actually a tool that we defined. And let's look at how the crew is defined. So the quest crew and the LLM that it uses to accomplish the task. In this case, OpenAI LLM GPT-4o. It can be also have tested against Anthropic, also the Grok Llama 3 model. So Anthropic and OpenAI model gives you quite very good results, in fact. And here's the agent defined, the business consultant, and here's a reference to the agent YAML and task YAML files that we have defined here, from where the actual role, the description, everything will be derived from. So business consultant and generate question task, there are two. And then the output given in the Pydantic question list. So that's a Pydantic list that you have defined here. So that's a quest crew, and then there's a EDA crew, which is again using the same LLM model, and data scientist and agent, and data science as a task. It's configured. So now we have defined both the crews. Now we will basically set the sequence of execution for the crew that's in the main.py file. I have created certain utility classes to read the file from the this is for reading the metadata file, because metadata is given in a text format to read the content of the metadata, and this is to generate the markdown for images, and this is the run. So when you run the crew, this is what happens. It starts the execution. I've also used agent ops. There's a platform which actually can track the capture the traces of execution, which will be fantastic for debugging or monitoring later. So I will go through the tool as well at the end. So you read the YAML file. So YAML file config YAML, which is actually captures the number of questions to be asked, metadata, the data path and all that. And then once it reads it, then start the session, and then we start the quest crew, and it requires two inputs: how many questions to be asked and the metadata info, the content of the metadata file. That's all is needed here. And then kick off the crew with those inputs, and this is going to create the questions, and that will go into queue result, and then end the session. So that is basically generating the questions on a hypothesis, and once it is done, then we'll go through the questions, because the queue result is actually written in a pedantic class that we defined. If you remember in the CrewAI, the quest crew returns actually in a pedantic class. So we'll iterate through that and actually create the input for the EDA crews. So EDA, depending on two questions we ask, if we ask two questions, there will be two EDA crew will be created. So where we are going to send the question one by one, and the metadata file again, the data path which is necessary now, because ultimately the EDA, the data scientist agent, is going to run the code against the data set. And this is the image path directory in which the image would be stored once generated. If at all the task generates any plots to answer the question, it's going to store them, and now that path will be embedded into the final summarization document. Then start the session, and this is interesting. EDA crew, you can kick off for each. This is an interesting API given in CrewAI for each EDA input list, right? So I'm going to go through each question and create this EDA input for each question, and the remaining ones going to same, but the image path is also different for different questions. So with different questions, the plots generated are different, they are stored differently, making it easier to embed into the final document. And then we'll kick off this one. So this is going to run, if there are two questions, it's going to run two EDA crews one after another. If there are n number of questions, it's going to run n number of times. And then finally the results are written. And how these results are, we have already seen in the EDA task. The result should be in the format of markdown, which will contain question, code output, and the analysis of the output, summarization of the results. So what do is now I'm going to create this markdown, final markdown, and which will have the dataset description, then iterate through the final result and write each section like EDA analysis 1, 2, 3 depending on the number of questions, and also going to embed the images. So this is the complete implementation. So you create the crews, define the crews, and define the processes, the sequence of execution of the crew. The CrewAI agent, all you have to do is CrewAI run. So this is a run already completed, and you can see it starts the agent execution. The first agent is the business consultant, and it is a task for the business consultant, and you can see the metadata is already embedded into the task. and that's a final answer that's generated from the agent, the task. And you can see there are two questions generated, and then it has entered the data scientist crew, which whose task is to take one of the question and start answering those questions. And you can see the data scientist agent's output. It's actually using the tool, which is a Python REPL tool, and this is the input. So it has generated the code here, and that's a tool output, the output of the code, and that's a final answer of the data scientist for the first question. And as we specified in the task, the expected output is in markdown format. And you can see there's a question, the code output, and the final analysis. And this is done 2 times because there are 2 questions are there. And then finally both the question and the summary of both the responses is put into final markdown document and stored as an MD file. And this has executed under 1 minute, and the cost of execution probably less than few cents. And I'm going to write a blog about the detailed implementation of this and post that link in the YouTube description. So please make use of it and let me know your thoughts, and if you can improvise on this and do something more wonderful, please let me know. And thank you for watching this video, and see you next time again. Thank you.